That's better. Wow, that's better. Great. Okay. Welcome to week 2. Wow, it's already looking like spring out there. So, well, it's supposed to rain tomorrow, but we'll see. Okay, great. I'm very pleased to see you all survive the bits and byte manipulation from last week. So starting today, we'll start coding. And in case any of you have not written a C++ program before, raise your hand if you've never written a, well, let's wait for other people to switch on the cameras, and then we can raise hand and all. Well, in the meanwhile, actually, we're waiting for other people to join. So, so feel free to talk, okay? Feel free to talk, ask about any questions you have, anything related to the course, or even, doesn't have to be directly related to the course either, because we haven't actually started, started class formally today. So, any questions you have, I'm happy to answer these questions before we get started full swing. And today, we will actually get one of you, well, many of you, hopefully, actually all of you to code your program in C++. And if you've never coded and executed a C++ program, this will be the first. Actually, oh, I had a piece of cloth here. All right. Well, anyway, so if you've never coded C++ before, this will be your first program, and you'll actually code and run a completely functional C++ program. And it may be your very first program. So, maybe later on in time, when you're like this rock star C++ programmer, okay, earning 7 figures in salary, or, having a chairman of this huge company, you can say, hey, you know what? Look at this video. That was the very first C++ program I wrote. Okay. So that would be really cool. So, every one of you will get a chance to code live on screen. I think last quarter, every single student got a chance. Okay, you can check. You can go to the Reddit and pick random people off the previous quarter class and ask them. I'm pretty sure that everyone will say that they all got a chance to code on screen. It's actually it's a great deal of fun and also very instructive. Okay, it's very instructive. And the reason I say it's especially if you've not programmed a lot in C++, okay, the more experienced people who've already coded in other languages, they can hold off before volunteering when we get to the more challenging parts. Past week 6, we'll start writing smaller, slightly larger programs. But until then, the people who have never coded before, never had any experience in C++ or any programming language, they're the ones who should volunteer, because it'll be very, very useful. And the reason I say that is because, and I think it was a chance discovery when I was teaching face-to-face a long time ago. So, and I used to, just like this, right? I used to say, well, this is what we're going to code. All of you code, and I'll just come around and look at your laptops. But then I realized one day that, this could actually be coded on the whiteboard. So I asked a student and put her on the spot and say, well, you're going to code it, well, with her permission, of course, you're going to code it on the whiteboard, and we're all going to watch. And she was like jittery and, and is really, really nervous about doing this because, public speaking is hard, but public coding, when everybody's watching and you got to code and this, you could make errors and embarrass yourself. There's no such thing as embarrassment, really, but people think they get embarrassed, right? But then I noticed something really, really cool, right? But after she did that and went back to her seat, and later on, she came to my office and said, that was the most useful thing I've ever done in class. And I think the reason for that is because when I was coding, I could not afford to be wrong in front of everybody else. And so I was like super duper engaged. Everything I was writing on board, I wasn't like letting my mind wander. So I was actually on the ball every single time. And later on, after I finished and went back to my seat, and when you were explaining things to other people, I didn't actually need any of that because I actually understood everything. So it is actually very instructive and useful, and it'll save you like several hours of work later on trying to read some topic and trying to master it, if that topic was what you coded in front of other people, right? Because it actually helps a lot. So Yuhao, David, Michael, Charlene, you got two screens. Someone's got their microphone on, and it's interfering. Charlene, is that both Charlene's are the same? Charlene and Charlene Lizard? Now there's only one. Well, there were two Charlene screens before. Okay. Well, anyway, Justin, David, Michael, and Charlene, switch on your cameras, and then I think we can get going, right? Can we? Yeah, well, all right. 2 more minutes. Ask me any questions if you have, and otherwise we'll just get started coding, okay? And we'll ask for a volunteer. Someone can pick up the screen, and then we'll jump in. We'll jump in. Yeah, this is like swimming, okay? This is, in the beginning, maybe they teach with, I know this is what you got to do, this is what you're going to do, and so on. But at some point, you got to get in the water, and I think that's what we'll do. We'll just dump you all in the water, but knee-deep water, okay? And then I'll be there with you, and saying, well, don't put your face underwater, and you'll be safe. And that's all we got to do. And so we'll do that today, okay? Oh, I see. Charlene has, computer issues. Okay, that's fine. But David and Michael, you got to switch on your cameras, okay? All right. Okay, how about if you don't have any questions for me relating to last week, relating to class mechanics, relating to other stuff that, peripherally related, ask me now, okay? Otherwise, we'll just start coding, and we'll pick a volunteer, and then we'll share screen, and then we'll go from there, okay? Okay, David, all right, hang on just a second. Yeah, okay. Yeah, no worries, okay. All right, great. Okay, good. So who would like to code today? It's going to be very simple, okay? We'll start off very simple. We'll start off very simple, and depending on your comfort level, this is what we're going to do. Just like in swimming, okay? Depending on your comfort level, I'll say, let's do the next thing, right? Let's try something a little more challenging, and so on. So I'll stop pushing when I feel, or I get a sense that it's probably too much for one class. I think it'll work, okay? And you guys can always tell me. You guys can tell me and say, hey, that's enough. We want to play around. Actually, we'll do that too, right? After we code a little bit, we'll just say playtime, okay? So 10 or 15 minutes, maybe even a half hour, if it works out that way towards the end of class. We'll say it's playtime, and you guys are just going to code random stuff, anything, take what we've done already and make modifications to it, all of that. Everything is open and fair game, okay? So we'll do that. How about someone who has never coded in C++ today, but has a computer that can share the screen, right? You got, and before you share the screen, the only thing I want to, since all of you are here, well, most of you, some of you are still absent, okay? Somehow you got to reach out to the other students who are not attending class and tell them that attending class is like super duper important, okay? It's not only for with the view of picking up the material that's shared, because people always say, I used to do that, but then I learned the hard way saying I shouldn't be doing that when I was a student, okay? When I was a student, that's not a good idea, because it was, if I used to think that, I can cut class and then read the book or read the notes or talk to my fellow classmates and pick it up later. And it used to work for some of the earlier stages in my, school, right? But then as I went on to the more challenging stuff, I found that was actually harder. I could eventually read the book and ask people and work through things on my own and learn it. But I realized later on that is not a very computer or a scientific way of doing things, because when you have an easy way and a hard way to do things, what would most intelligent people do? They'll pick the easy way to do things, right? They wouldn't say, I'm going to do it the hard way, right? Especially if the hard way is not going to give you any added benefit, right? So if you say you do the harder way, I'll give you more money or more happiness. Yeah, okay, then it makes sense, right? But if everything else being equal, as an easy way and a harder way, you shouldn't do it the harder way. You should do the easy way. So easy way is to attend class, okay? Because you can assimilate stuff at a faster pace in class than by reading the book on your own. I can tell you, maybe it's not the case for you, okay? Maybe it's not the case for you, but when you're actually thinking in real time, dynamically with someone else, trying to follow a conversation, right? Trying to follow a conversation with someone else, and thinking on the spot, rather than having to refer back to a book saying, okay, well, that person asked me what my name is, let me see what the best answer to that question is. Okay, all right, that's my name, right? So that doesn't work. You got to be thinking on the fly. And that and once you start getting into the hang of thinking on the fly in any art, not just programming, any art, it just comes naturally. And I feel that I suspect, right, that the people that are not making major strides, right, major strides in any field they go into, right, whether it's programming or music or whatever it is, well, I don't know where I was going with that. I forgot. Okay, so let's not waste time talking about that. How about someone else? Just as someone pick up the screen. Who hasn't coded in C++ before? Just raise your hand if you've never coded in C++, and we'll pick you up. Okay, we got Mohammed. Who else? Everybody else has coded already. Omar. Okay, and I'm not. Okay, so we have a few people. Mohammed was the first person to raise his hand. Hey, Mohammed. Is it maximum brightness of your screen, by the way? I'm talking about the screen, not the backlight. Yeah. Okay, good. Yeah, that's much better. So you can see your face and all. All right. So you have a computer, you can share your screen?
Yeah.
Great. Okay. All right. So how about this? Yeah. So the only thing I want to caution before people share their screens is that sometimes we will just be opening up a Chrome browser or a Safari browser or something like that, Edge, and doing stuff inside of the browser, because there are so many online coding environments these days that you don't really need a full-fledged IDE like VS Code or Xcode until you get to about quest number 5, right? 6, right? Well, maybe 5. Okay, until about quest 5 and 6, slightly more involved quests, you don't have to get into that. So you have a bit of time to get used to the IDEs, integrated development environments, that all the professionals use, many people use, right? So, but for now, initially we'll use the Chrome browser and code inside of the browser. The only thing I want to make sure is that before you share your browser screen, make sure it is a private browsing window. Okay, private meaning incognito in Chrome. Just make sure it's private. And the reason I say that is because even autocomplete in the URL bar could bring up your social security number. I don't know, phone numbers, whatever it is, right? Phone numbers, driver license stuff that you filled in. Why don't? And then I can't make that video. I can't publish the video after that. Okay, I have to go in and edit it, and then I'll put it in the back burner saying, okay, I got to edit that video. All right. So, go ahead when you're ready. Just share a well, that's better. Okay. Yeah. Great. Okay. All right. So here's what we'll try and do today. We'll try and code the very first. Hey, how about this? How many of you, by the way, how many of you have completed the first quest? Okay, the very first quest. Okay, Mohammed has. All right. So there's how many of you have not completed the first quest? Okay, that's actually a much better question to ask. Yeah. Okay. Good. Okay. So how about this? Would you like it if we just coded something similar to the first quest and went all the way through? Dragging and dropping and getting the results and everything, because it'll just be a walkthrough. And first quest is a piece of cake, and so you don't. Yeah, we're not giving away anything by doing that. So how about that? We'll do that. Okay. So today we will do the first quest. And let me go through the whole motion, right? So just so people understand what is required of all the quests coming up. So let's just go to the Quest's website. Just go to the Quest website, quests.nonlinearmedia.org, right? Quest. All right. Now, type in a tiger name, thanks. Yeah. All right. Now, when you click on the big red circle, just click on the big red circle, you get the specifications of the, or you can also click on the link, right? So these are, and someone in 2C said the PDF viewer is a little hard to read. And, you can always click the download button if you want. Don't do it now. You can always click the download button and you'll have a PDF. And you can view it in a separate window after that if you want, while you're coding. So, but we won't do that. What this quest is telling you to do is to write a very, very simple C++ program that you can run, and it'll just print hello world. That's all. Okay. And it also says that this C++ program is practically given as a freebie. If you go to any online, any programming environment, right? Even an IDE like Xcode or VS Code, you say, I'm going to start a C++ project, it'll automatically give you a hello world, bang, like that, right at the word go. And that is exactly what you need to code for this quest. Okay, so let's now go to the, well, you can page down a little bit more to see if you want to see the sample code and all. You see that code, right? That's essentially what we're going to be ending up writing today. So now let's go to, so in this case, we won't use online. Okay, we'll use Notepad. What is this? Is this a Windows or
Windows.
Is this Windows or
Windows? Yeah.
Windows. Okay. All right. So let's use Notepad. Do you have Notepad?
I don't know.
Oh, yeah, I'm pretty sure. So click on Explorer and then you just type NOTE.
Oh, yeah.
What editor do you use? You can use any editor you want, right? So do you use a text editor of some kind?
No.
All right, so let's use Notepad, right? So click Explorer and type NOTE.
Yeah.
It should autocomplete for Notepad. Do you see the
Mhm.
autocomplete for Notepad?
Is it not this?
No, this is just the browser. This is the browser.
Oh.
We want a Notepad, a text editor, something that lets you create files. If you want to create files. So can you fire up Notepad? Do you know, do you have Notepad?
I don't think so.
I mean, do you have Notepad show up in the when you click the Explorer? You click Explorer, and then you have the search bar, right? You have a search bar. Type
Right here?
NOTE there. And do you have Notepad completed?
I have a Notepad app.
Oh, you are already in Notepad?
Oh, yeah.
Oh, why is it not showing up? Oh, maybe you got to share that window separately. Are you safe enough to share your desktop completely rather than just this window? Or do you have stuff on your desktop? Yeah, okay. If you have private stuff on your desktop, don't share it, but make sure it's clean and share your. One time there was a student who had her driver license photo. Yeah, maybe she was probably sending it to somewhere. And right on the desktop, and she shared it. Okay, great. This is what we want to do, right? So the very first C++ program, we're going to type it in by hand. What I just type in what I say, and then as you type it in, maybe it's all a foreign language to you. But then as you type it in, and then we'll go over the code, and then I'll explain it a bit, and then we'll see what we need to do. Okay. So let's say hash include, right? Hash. The hash is shift 3, right? Shift 3. Hash include, right? And then space, angle bracket, yeah, IO stream. So it looks like you've coded already, somewhat, right? Stream, and then close angle bracket. I thought you raised your hand when you said you never coded in C++ before.
I did the hello world thing, but
you did that. All right. Well, so that means technically you have coded in C++. That's okay. That's okay. All right. Okay. So hit enter. One more. All right. Now let's say using namespace standard. Okay. Using space namespace space. Using space namespace space. Using space namespace, and then a space after that. And then std standard. Okay. Semicolon. All right. Now hit enter a couple more times. Now this is the function. So all C++ programs are made up of functions. All right. A function is a tightly integrated one chunk of code that will get called, and then the function does its job and say I've done my job, and then return, right? And that function can call other functions. This is a part that is central to many programming languages, especially C++. So let me know if this is confusing, and I can explain it in different ways. But every program that you run will start off by the operating system, in this case Windows or Mac OS, right? So the operating system will pick up the program and look inside the program to see how many functions are there in this program, and is there a special function called main, because that is what the operating system knows to look for. The operating system will look for a special function that you have defined in your code, and the name of the function should be main, M-A-I-N. And if there is a function like that, the operating system will say, okay, I've got a function, and it's got a function, I've got a program to run, and that program has got a function called main, and I'm going to now give control to that function and say, hey, Mr. Main, go ahead and run. Now leave me out of the picture. You do your job. When you're done, signal back to me saying you're done, and then I'll tell the user your program is completed. Does that make sense? That's the entire cycle. That is a life cycle. The user types in saying, hello, so Mohammed says, at the prompt, at the C prompt, or Windows prompt, he says, run this program. Actually, the funny thing is, these days, many students or many people don't even know how to run a program by hand, right? Because everything is GUI, and people run programs by double-clicking on icons or tapping things on the phone. Yes? But, back in the day when I was learning to program, GUIs were not common, right? They were, GUIs were there, especially Windows and all, and Mac. But they were not so common. So many of us got used to program by typing on, creating things on the command line and running programs by hand. So, but essentially what happens is, even when you double click on an icon on a phone, right? Tap an icon on a phone, or double click an icon to run a program, all that is really happening is the operating system, Windows, right? It'll take that icon that you double clicked on, That icon has got an executable program somewhere on disk, right? It says, my program.exe somewhere. It lives there on the disk somewhere. So that is going to do what we will do by hand. What I mean by that is that we will take that program and say, at the C:> prompt, Windows prompt, we say, my program, hit enter, and then it runs. Yes, we will actually be doing that later on in this class. So you'll get a chance to see what's going on. But that is actually what happens, right? So essentially that program needs to get run. And so main will get run first, because main is a program that is called by the operating system. That is called the entry point. Every program has an entry point, and the entry point is where the operating system, Windows, will tell the CPU, here's where you start executing. Here's this big program. It's got a lot of steps in there, one after another. But this step is where you got to start. All right. And from then on, it'll just start executing sequentially. That's all that happens. Okay. So our main program, our main function is going to be our entry point. So let's define main. And in order to define main, we say int space main, and then open main, open close parentheses. Yeah. Open and close, right? And then space, and then a curly brace, space and a curly brace. Now, when I say space and curly brace and things like that, it's all just stylistic, okay? And it's my style. It doesn't have to be your style. And so you can follow your own style, but it's got to be consistent, I think, for other programmers to be able to easily read your program. It's just got to be consistent. Pick a consistent style and read it. My style is basically based on, the Kernighan and Ritchie were the people who popularized the C programming language, and they came up with a style, and I like that style very much because the style is done in the style is such a way, and you'll find out later on that programs are not too long. Okay, so what I mean by that is that sometimes people will insert lots of lines in their programs, and brace goes on the next line and so on. What I found is that when that style makes a 100-line program a 200-line program. No, it's exactly the same. It's not so much more. It's not more difficult to understand. It's just more pages to flip through. That's all, right? Or scroll through. So this kind of style that we're going to use kind of minimizes that. You don't have to flip through or scroll through a lot, and the whole thing is right there without extra cognitive load. So that's the reason I like this style. Okay, and your preferences might differ. Okay, so hit enter, and then what we're going to do is indent in. Okay, and again, indenting in is good practice because it makes your code easier to read for other programs, and for yourself too later on, right? Indent in. Now, don't do 8 spaces. Okay, just do 4 spaces. Well, yeah. Oh, don't hit tab at all, okay? Never hit tab. And the reason for that is, tab was originally designed for this purpose. People when, tab in and so on, that's what it was designed for. But unfortunately, because of historical errors and miscommunications, some people said, some implementers, right, said my tab is only 4 spaces long. Other people said my tab is 8 spaces long. So, sometimes when you, between programs even on the same computer. So when you say, I'm going to indent everything by 4 spaces, and then somewhere you use spaces instead of tabs. So the one with spaces will actually be indented exactly 4 spaces, but the one with a tab will look okay when displayed by a program that interprets tabs as 4 spaces. But when you look at it with a program that interprets tabs as 8 spaces, then your program looks all jagged. Because the 4 spaces will be here and the 8 spaces will be here. So let's just use 4 spaces and always use spaces only. And later on, when you code inside of programming environments, you can tell the IDE saying never use tabs, only use spaces. We'll come to all that later on. Okay. So all right. So tabbed in. Now here you want to say C out. That C out stands for console output, right? Console. The console is a fancy word. Okay, console basically means the screen and the keyboard put together. That's all. Okay, so console is screen and the keyboard. When you say console out, right, it means I want to send something out to the console. I want to send something to the screen. That's what a console output is. Console input is I want to read something from the keyboard. That's all. Okay, so C out is sending to the console output. It's a screen. C in is reading from the console, that is from the keyboard. Yeah, is everybody okay with this so far? Raise your hand. Yeah, okay, good. All right. So C out and then a space. And here we're going to use a special operator. Okay, now technically you say you could define a function. Go to the next line go to the previous line for a moment, right? For a moment, hit enter. In many other languages, you would have seen this. Okay, hit enter, and then a tab in now, right? And then in many languages, you would have seen this. Say print, open parentheses, right? Hello world inside of quotes, hello world inside of quotes, right? And then yeah, right, inside of quotes, that should be double quotes, yeah, double quotes. No, don't erase. Yeah, all right. So inside of double quotes, say hello world, and then after the hello world, we want to put a special character. Okay, a special character that is not a letter, but it is actually a line feed. Okay, a line feed is I don't know if any of you are familiar with the traditional old ancient typewriters, the mechanical typewriters, right? When you type something out, you want to go to the next line. What you do is push the carriage to the left, right? So there's two things happening there. Two things happening when you do that. If you should actually go to a museum or somewhere where they have a real typewriter and try it out, because you'll actually see two things happening when you push the carriage to the right. What happens is the carriage moves all the way here, or I don't know, right? Something like that. Oh, this way. This is come back to the left margin. That is a carriage return. The carriage returns to column number 0. But in the process, one more thing has happened. The roller that contains your paper has also rolled up by one space, so that when you start typing, it's not only column 0 of the next column, but it's also the column 0 of the next line. So you've gone line feed as well as carriage return. So carriage return and line feed, two things have happened. Now, in the world of computer science, what we've done is actually, let me change my glasses to the other one. I can read it, but still. All right, okay. So what we did was we said we'll split these up into two different characters. We'll say the line feed is a separate character and a carriage return is a separate character. Okay, so the line feed just takes you to the next line, right? The carriage return takes you to the beginning of the line, right? So when you on a console, when you hit the enter key, on a console, it does both of those things. It sends two characters to the console. It sends a line feed and a carriage return. That's why you go back to the beginning of the next line. If it only sent the line feed, you would not go to the beginning of the next line. You type something in and the line feed will take you right there, right? Not to the beginning, it'll be here. So you need to send a line feed and a carriage return to go here. So that's CR and LF. The two different characters, the special characters, are /R and /N. Now, as it happens, because for historical reasons again, right? So unfortunately, these things that I say historical, there's only 4 or 5 of those, I think, right? So, and we'll cover most of those. And so you don't have to worry, like, there's a history class, I got to remember like 5,000 facts, right? No, that's not like it, okay? So there's only a few of these things. And again, it's not like super duper important, but it's useful to know. So for historical reasons, we said the Windows people, the Microsoft people said, the carriage return, when someone sends a carriage return, I'm going to interpret the carriage return as 2 characters, right? Even though they're sending only a carriage return, I'll interpret that as CR and LF. Right? On Macintosh, it was the opposite, I think, right? They said, a line feed is both. I don't know, on Unix, right? So there was some mix-up. I've actually forgotten the exact mix-up. But on Unix or the C programming language, what we can get the effect by just sticking the new line character, not this new line and carriage return character, just the new line. You say after hello world, say /N. Okay, /N is a special character, even though it takes 2 characters to write down. It takes / and then an N, two things. It won't show up as 2 things, right? The 2 things are intercepted by the console guy, okay, inside of your program, inside the operating system. It says, hey, I got a /N coming in, right? And then it won't print /N on the console. It'll say /N means I got to go to the next line, and so it'll actually print both of those characters. So put a /N after hello world. No, after, just inside of the quotes, right? Because it is /N is just a character. /N is just a character like any other character. It's inside of, right? Right? Now put a semicolon at the end. Now, typically, this is how we do it in other programming languages, right? In C++, it's slightly different, okay? In C++, we say, well, you know what? We got the console. It is an object. It's not a function. The C out is actually an object that understands. So that is the thing about C++. Everything is made up of objects. Even the console is kind of objectified, personified or objectified into one thing. So it's got a console has got these. So the screen is given to you as an object called C out. And when you send things to the object, that object knows what to do with it and will call the appropriate function. So in other words, the console is not just one function that says, I'll take whatever you say, give me, and send it to the console. No, there's actually a lot of functions built into the console, because you can do a lot of things to the console, right? You can send things to the console. You're just talking about output here, right? Or you can say, before I send something to the console, I want to make sure that the console is in a state that interprets numbers as floating point numbers, right? When it prints numbers out, I want to print 5 decimal places. So you can do a lot of these things to the console. Or you can say, I've sent a lot of stuff, it's not come out to the screen yet, which means it's in some kind of internal buffer. I want to flush the console, saying, hey, whatever you got in a holding buffer, send it to the screen right now. So there's a whole bunch of things you can do to the console. So that's why in C++, we said, well, we're not just going to have a simple, print statement. We'll just give you a console object, which can do a lot more than print, right? So you send stuff to the console, and the console will know how to do it. So the way to send stuff to the console is by, using an operator. An operator is something like plus, minus, times, and so on. 3 plus 4, 5 plus 7, and so on. It's just an operator. And an operator, it will say, 3 plus 4 is basically the function for plus. There's a function inside your program. It's already been written by the C++ designers. For plus and all, it's basically part of the assembler itself. And it comes with the chip, right? But it's still a function. So the plus function will get given these two things, right? Hey, plus, I got 3 and 5. Hey, do your job and give me the result. Okay, so it's going to get called. The plus function is going to get called when there's the operator encountered, right? So like that, we're going to see how it defines an operator. So the operator is called the left shift operator, right? So the left shift operator is used for other things later on, but C++ gives you this really, really nice feature whereby you can take any operator, plus, minus, divide, whatever it is, and you redefine it. Right? You can say my plus operator does not do plus, my plus actually does minus, right? My minus does times. So you can actually redefine everything. You can have your own mathematical world in which the operators do completely different things. C++ lets you do that. However, beyond students who are trying to do crazy things, people don't really redefine operators because they want to stick to the conventional notations and the meanings. So, however, in this case, there's an operator called left shift. Okay, left shift. And left shift operates at the bit level. Okay, so in fact, when you read module 0, you might have noticed that if you take a bit pattern and shift all the bits to the left by 1, shift all the bits to the left by 1, what happens? What is the net effect of taking a bit pattern and shifting all the bits to the left by 1? What happens? Take a guess. It's really cool, right? Because it's like super duper efficient way of doing something, right? So what happens if you take a bit? So forget about bits, okay? That's what I said. Last class I said anything if it's a question with bits or bits or binary digits, just imagine you're not in binary. Okay, so ask yourself the same question in decimal and say, I have a number written down in my social security box, right? 0000473. Something like that. Okay. Now I want to take all the numbers in there, shift them to the left by 1, and and the empty space I'm just going to fill by zeros. Empty spaces will get, and whatever is shifted off the right disappears, gone. Okay. So you got a bit number, a bit pattern, or binary number. In that case, you don't have to shift off at all. It can be infinitely long, right? So you take a bit pattern, 5453, right, and you're going to shift it to the left by 1 space. What happens?
Would it be multiplied by 10?
Yes, thank you, Namrata. Okay, so that's exactly what, so 453, push everything to the left, it becomes 453, and this blank space becomes a 0. So 4530. So 453 becomes 4530. Yes. So each time you shift a decimal number to the left, it is multiplied by 10. And exactly the same thing in reverse. If you shift things to the right, it is dividing by 10, right? 453. Shift to the right by 1, it becomes 45.3 because the point is on the right, right? So, or if you can't store the fractionals, you'll discard the 3 and it'll become 45. So it's 453 divided by 10. So if you shift to the right, it gets divided by 10. Shift to the left, gets divided by, multiplied by 10. Same thing with binary, okay? So if you shift to the left, it is divided by, if you shift to the left, it is multiplied by 2. If you shift to the right, it's divided by 2. Yeah, so there, that is the operator, left shift. It's called the left shift operator. So, and it's 2 less than signs right next to each other. They've got to be right next to each other. Okay, so after the cout, say 2 left shift signs, two less than signs, 2 less than signs. No, 2, not the number 2. Two, yeah, 2 of these, 2. Yeah, all right. Now, space after that. And say hello world, and then the /n in quotes after that, right? Hello world. Yeah, right. So there you go. Fix the spelling, and then okay. All right. Now close it, and put a semicolon there. Right, now let's put some comments. Now go to the beginning of the print statement, the above, above. Go to the beginning and put 2 forward slashes there. Okay, that means that comment, that statement on that line has effectively become what is called a comment. Okay, a comment is a statement that is not interpreted by the compiler. It's as though that statement that didn't even exist there. Okay, it's, you basically remove the statement from there, except it's there for humans to look at. It's still there. It's a slightly safer form of deleting the line altogether, right? So many times when programmers are coding and they want to change their program here and there, they won't make final changes to the program when they're not sure if what the change they're making is a good one or not. They won't make final changes. What they'll do is just make tentative changes, and tentative changes are saying, I'm not going to delete whole chunks of the program because I don't know if it's right or not. Yeah, okay. Peter is here. He wants a cookie. You guys want to see? Right. Right. There you go. Here. Can you see him? Pin this for a sec. Okay, I'll give him a cookie, and then we can here. It's a squirrel. There's a couple of live squirrels. The thing is, there's a whole bunch of them now. Unfortunately, they're all called Peter, so I don't know. Why is? Oh, I got to remove the pen. All right, good. All right, so that thing there is called a comment character, and that says I'm gonna take that line and make it invisible to the compiler. Only humans can see it. The compiler cannot see it. Okay, so that's a way in which you can preserve code that you're not yet sure if you can delete, but it'll still be there. Okay, so now go on all the way to the right of that line, right? A couple of spaces now. Right, and open another comment there. Open a comment. Yeah, that's a line comment. Okay, and inline comment, and say this is how you may expect other programming languages to do it. All right, or you can just say how. Right, this is how some other programming languages may do it. Right, say how other programming languages may do it. How other languages, right, or yeah, programming languages may do it. Yeah, may do it. Right, you got it's a spelling errors. So languages fix. Yeah, and I'll say change that to G, and then languages also. Lang. You got 2 G's there. L-A-N-G, U-A-G-E-S. Yeah. Okay. All right. Now on the next line, we want another comment lined up right under that, and you say this is how we do it in C++. That's all. This is how you send output to the, this is how we do it in C++. All right, okay, so next line, hit enter. And then traditionally, conventionally, I shouldn't say traditionally, conventionally, or this is my convention, I don't know, right? What I do is I separate out the return statement by a blank line above that. Now, what I mean by that is, previously I said we need to keep our programs short, so it's manageable and you don't have to scroll a lot, but still at the same time, it is useful to have blank spaces in the program, right? Because, think about English essays. You can't write, one monolithic paragraph and give it to your teacher. She'll say, go back and, break it up into, coherent chunks of thought. So that's how we do it. Even in your programs, you'll be writing lots and lots of pieces of code. Each of them may be self-contained logic, then what people do is, that is self-contained logic. So the next part that's going to come is a different paragraph. So I'll have a blank line between them. So return is a separate paragraph for me. So I just say space and then blank line, indent in, and say return 0, right? Indent in, 4 spaces in, and then say return space 0, and put a return space 0 semicolon. Right now, again, indent in and put a comment on the same line, inline comment, right? The spaces and then a comment there. And then you can say 0 is the value this program gives back to the operating system.
Can you repeat that?
Returns to the operating system, right? Returns to Windows. And within parentheses, you can say or Mac, right? Or Mac OS, right? Or Mac OS, right? Mac OS. And then within parentheses also you can say indicates 0 errors in the running of this program. Indicates no errors found. Indicates no errors found. Yeah. All right. So fix the All right. Cool. All right, so now on the next line, and then we'll close the brace. Close the brace on the next line. Now, that is your very first program, and it would also it is also your solution. The very first quest, the tiger name fangs. That is the solution to the quest. So what we'll do is now we'll save this program. Save this program as it'll ask for a name. Put it on the desktop. Put it on the desktop so it'll be easier. If you want to delete it later on. Looks like you also have VS Code and Visual Studio compiled and all. Put it on. Oh, you already have a file called helloworld.cpp.
Yeah.
Oh, that is what you submitted.
Maybe. I don't know if it's this
All
one.
right. Okay. Basically, this is going to be pretty much the same. You know what? Before you overwrite it, you can delete it later on. Just click one time on the helloworld.cpp. Just click one more time. One more. Just one more click. Yeah, all right, good. Just rename it to .org. No, .cpp. .cpp is fine. Helloworld.cpp, which is the name you originally had. Hello world.cpp, right? No, .cpp, because we want to also tell yourself that it is a C++ program. Now after that, orig, not org, right? Orig, O-R-I-G. That's another convention that programmers use when they have files and they're not really sure if they want to delete a file, but they're working on some other file. They'll just rename the old file as .orig, because if they totally screw up this file, they can rename the old file back and start again from scratch. Yeah. So that's all. All right. Okay. All right. Good. So now you can save your file as helloworld.cpp. Yeah. Why does it say it already exists? No, why does it say it already exists?
I don't know.
Oh, you know what? Oh, there is a file called helloworld.cpp still. No, maybe that's the .orig file. No, all right. So click no, right? And cancel and come back. Cancel and come back to this and save again, right? Save again. I think what happened was just that, that dialog didn't load now save it as, go to your desktop and save it as helloworld.cpp. Okay, good. All right, so now you can close this program out. You can close this out. Now let's go to your questing site. Yeah, there you go. Right now here, this circle is where you want to drag and drop that helloworld.cpp file. You want to drag that in here, and yeah, there you go. No, not the original file. Yeah, that one. Just drag it from there. And yeah, just yeah. All right, cool. That's great. Okay, that's all. So you drag it there and you click it, and then you know what? Oh, don't. Oh, it actually does work. Sometimes the picture, I'm pulling these pictures from Open Images or something like that. Some I've forgotten. So I'm pulling these from, and sometimes that site is down, so that and when people submit something, they don't see a picture, but they just see a broken image thing rolling around. It doesn't happen all that often, but I've never seen that. But I was thinking that maybe it'll happen here. Okay, now you can click on it, and then you can see the result. You can see the result of your program. Click on, yeah, you can test output, or you can click on There you go. So why does it say 0.917? Oh wait, maybe it's missing a. Oh yeah, okay, all right. So you didn't get full trophies because it is not exactly the same as what the site wants you to do, right? There's a slight difference. Can someone tell me what the difference is?
The caps.
Right? Yeah, that's right. Yeah, right. So on the left is hello world, both caps, H and W, but here W is not in caps, right? So if you fix that, we're not going to do that now. But that's all it is, right? This is basically a walkthrough of the very first quest, and you also got the password for the second quest. Yes. So those of you who haven't quested at all so far, this is your walkthrough. So this is how you do every single quest. Every single quest, you're going to create files, grab the files, put it in the circle, hit it, and then wait for the result, and it'll tell you how many trophies you got, as well as, and in fact, if you put a student ID, right? So go back to your file, go back to your file again, go back to your file. If you edit the file again, right? Edit the file and go to the very top of the file. No, not, oh, I see, because it's I can do it. You can do it in Visual Studio, that's fine. That looks right. Go to the very top of the file, yeah, before that, and two comments there, two comments. Yeah, even before that, the very first line, it's better because this is not part of the program at all, essentially. So yeah.
Wait, how do you go before that?
Yeah, right there. Hit enter.
Oh,
Yeah. All right. So now put 2 forward slashes, and then space student space ID colon ID colon. Now, and now don't put your ID there. Say Mohammed, or say Mo, or just say Mohammed. Right? Yeah. All right. Good. Right. Now submit it. All right. Good. Is this one? No, this is the old one, right?
Yeah.
So again, is this the new one or the old one?
It's the old one.
Just submit this one. Okay, now all you need to do after it comes back, we know what it is, right? So you can click it, you can see the result if you want, but you don't. All right, so now go to the URL, and where it says quest.nonlinearmedia.org, just delete everything after that. Instead say /q, right? Just delete everything after that in the URL bar, right? You want quest.nonlinearmedia.org, but delete everything after the slash, Yeah, right now say /q there, right? Hit enter. Now, yeah, so here you can, as soon as you submit, you can go to the site and you can look at your entire history, okay? All the quests you've submitted, all the, how many trophies you got, when you submitted, and everything will be shown here. And you type in Mohammed, and you type in whatever you put in after the student ID, okay? Say Mohammed. Yeah, hit enter, and it'll show you. Hey, what happened? Why didn't it show you? Is it the same as the other? No, what happened here?
I think if we go back to, open that, back to your code, there might be a typo. Oh, doesn't matter if student is spelled incorrectly. There's
yeah. Hey,
okay.
No, 2Ds, 1D. Thank you. Yeah, was that Omar? Did you notice that?
That was me, yes.
Totally missed that. Okay. Yeah, can you, and while you're at it, just correct the W also. Make it lowercase w. All right. So now if you do it, you should actually get one whole trophy and the password, and also you should be able to see, this. You need to go back. You can just go back. Yeah. Yeah. Now, drag the new file in.
I don't think you saved it.
Oh, you didn't save it?
I didn't.
Oh yeah, go yeah. Save it.
Also,
Yeah.
I think you only changed the print one, not the actual cout.
Oh yeah. Thank you, Erica. All right. Okay. Great. Okay. All right. Everything else okay here? Yeah, I think so. Seems like that. Okay. Now, yeah. Drag the file. Hey, before you drop it in, yeah. No, that's fine. Just. Oh, I see you did it already. Okay, that's okay. I wanted to see if it also works in Windows. Basically, if you grab something and just hover over a window in the back, that window automatically, just hovering over brings it to the front on a Mac. I don't know if it happens here. Okay, now if you go to the /Q site, if you go to the /Q site now, you'll actually see that, Mohammed has the trophy. Yeah. Hey, what's going on? Let's go back to your file. It's really funny. Why go back to your file again? Student ID : do you have no go back to your file.
I don't think I submitted it correctly.
Oh, I see. Okay.
Yeah, it's just done now.
Okay, good. I think this should have worked. Yeah.
Yeah.
There you go. Okay. All right. That's all. It's very simple. So you create a file, drop it in, and every single quest is just going to work like that all the way to 2C. Okay. And later on in 2B, in 2A, you may, I think even in the next quest, you may have to drag, create 3 files and drag all 3 files in. That's all. Okay. And so on. So you'll end up dragging multiple files. Okay. So that is the very first C++ program. So if and we won't be doing the rest of our class, you can close this window. Okay. I found out later on, see this gradient here on this page, the color is changing and all gradually. Now I just downloaded that code from online and then used that to make this page. But I realized later on that this is not a very efficient, whatever that code was that I downloaded, not efficiently implemented. Okay, so that's the danger of downloading code online and not looking at it carefully enough and saying, oh, it does a job, I'm going to do it. But they may be doing it in a very inefficient way because that person may not be a really professional programmer, or maybe the professional programmer, but they don't have the foundational knowledge in C++, or no, not C++, foundational knowledge in computer science that says this is how you do efficient things, right? So, and the reason I say that is because this page, if you just do nothing at all and you just leave it like that, in 5 minutes, the fan on your computer starts going, okay, and the computer starts warming up. That means that it's crunching. It's doing a lot of number crunching and it's driving the CPU just to get these color changes. Now, there's this whole thing could have been done more efficiently, not having to do so much CPU crunching. But unfortunately, I never had the time to go ahead and do it. So that's why after checking your scores, if you don't want the fan to start, just close the window. So don't have this page on for longer than you need. All right, so that's basically it. So that is the very first program. That is how you created the program. That's how you do the quest. Now, if you are all happy with it, what we'll do is we'll just go to an online compiler. We won't use VS Code and all for the rest, for the next 4 or 5 classes. Okay, we'll come back to using VS Code and Xcode for the slightly more involved projects down the line. But for now, we'll not use VS Code. We'll just go to an online compiler. So go to the URL bar and type onlinegdb.org, right? I think it works, okay? Online GDB. In fact, you can just say online compiler. Just say online space C++ compiler. Online C++ compiler. Yeah, and also say C++. Also say put C++ at the end. Yeah, all right, okay. Right, hit enter. I think you'll see that. What's the first one? Yeah, online GDB, that's the first one. Okay, still the first one. So this is where hey, look at that. Okay, this is the first quest and it's already there. Except, if you submit that, you'll only get 0.9 trophies, or you won't get 1 trophy, one whole trophy, because it's missing the new line at the end. And I think the W was capitalized or lowercase, right? So you got to fix these things, but it doesn't matter. This is not what we're going to do, right? So this is your very first program. It is given to you as soon as you start coding. This is a program you get. Now, in a few classes from now, I'll also show you how to compile things on the command line and run it and show you where the compiled code is, right? Because this program is written in something like English, right? C++, at the end of the day, is a human programming language. Humans are able to read it and write it. So but the CPU can't read it. The CPU cannot run this program. It is for us. So in order for the CPU to run it, you need to give it to another program called the compiler, okay? The compiler will read a program that kind of is like human-like. It's like pseudocode. This is like C++. So the compiler can read this program and translate it into a different language that the CPU can understand. That is all machine code, right? The machine code is of 1s and 0s, right? They're just made up of bits and bytes. So that compiler is going to take that program and turn. And on Windows, the compiler program traditionally is named with .exe on the end. So if this is hello_world.cpp, the compiler will turn this into another program called hello_world.exe, right? That exe program, there's no use for humans to actually open up the program and read it. In fact, if you try to open up a notepad or something, it'll say it's a binary file. Do you really want to open it? Because, you know, you can't read a binary file, but the CPU can read it. So that's why the .exe files are for the CPU to read, not for humans to read. The corresponding profile, which, you know, we use the same name so that we know they match up, the hello world.cpp, that humans can read. So we can read this file and the compiler, and I'll show you how that happens later on when we go to compiling on the, you know, on these things. But here, what we'll do is if you just hit there's a run button somewhere. Green run button. Yeah, there you go. The top, yeah, on the right, on the right. Yeah. If you hit the run button, it's going to do exactly the same thing. It'll run the program and show you the output. There you go. That's the output of the program. Now you can change this too. You can change hello world to something else, right? Hello world, I'm Mohammed. Say, you know, hello world, full stop, say I'm Mohammed. You'll say hello world, I'm Mohammed. Yeah. So you can say you can say anything you want, right? You can say anything you want. You just type in a whole bunch of junk there. You'll see the whole bunch, you know, all of that come up, right? Hello world, hi. Yeah, so that's how you send things to the console. Now let's do one more thing here. Let's say we want to accept input from the keyboard, right? So you want to ask the user, hey, what is your name, right? And then say, hello John, how are you? Hello Omar, hello Mohammed, right? So it's got to ask the person's name and then respond to that person by name. So that is the next step we're going to do. And let's still go with Mohammed here. Okay, so Mohammed, are you still happy to code this part? And then we can get another person to code, you know. All right, good. Right. So what Mohammed is going to do is basically going to ask the user before the cout that, in fact, you can delete the whole thing. In fact, for good practice, hit Control A and delete the whole thing. Hit Control A and delete the whole thing. Yeah, okay. So for good practice, because this initial part is just template code, it should just be read off from memory. Bam, like that. Okay, so now what we're going to do is type in a new program, and in this program, let's put up we'll start this program off by putting 2 comments right at the top. Right, and say class code for today's date. This is what the convention we followed in previous classes. If you look at the recordings, class code for what is today's date? Is it 17 or 18?
17.
17. Okay, class code for Jan 17. All right. So and on the next line, you say in this program, we will ask the user for their name and then greet them by name, right? Ask the user for their name and greet them by their name. By name, yeah? And THEIR, by the way, THEIR. Yeah, the other one too. Right, good. So this is what we're going to do. Now, you know, EIR. Right. So on the next line, can you type in by actually not Mohammed, okay? Someone else, not Omar, not Mohammed, not Erica, okay? Someone else who hasn't had a chance to voice their suggestions should call out the code that Mohammed is going to type. Okay, so Mohammed is now going to perform in the capacity of a pure typist. Okay, he's not a C++ programmer. He's just got his ears on. He's going to listen to what one of you is going to say and type it in. Yeah, Mohammed, okay with you? Okay, good. All right, so someone call out the basic template code. You don't have to do the the whole thing. We just want to get to the place where hello world is printed. Okay, so just call out the hello world program altogether from the start. Hash include using namespace, main, and so on, and return 0. Just fill in that template. It's just a very simple template. It's just basically nails it to our head and saying that's how we start. Okay, any complex program you start, that's it's a good way to start. It's like the writer's block. The writer's block, same as programmer's block. Many times in the past, when I wanted to do a bigger program, I get this programmer's block, writer's block. I know what to do, but it's really hard to get started. Saying, well, you know what, I do this and do that before, and it never gets started because that thing is there. It's looming in my head. What I do is the way to get over it is to just start small. Just start with something. In fact, this is what your English teacher would probably recommend to you also. If you have to write this essay, right? And people always sit in front of a page with a pen and say, well, or, the first word is the hardest to get out, right? The first sentence or first paragraph, that's the hardest to get out. But after that, things start flowing. And the way to get the flow going is essentially just to start typing whatever the hell, right? So just type, I'm not talking to you in English, for example. Just start typing anything, pick some random passage and start typing it, one paragraph. By the time you get to the end of the paragraph, you already start having ideas how to change it, and then later on you can go and delete the first paragraph. You have your own stuff under it, right? So like that, when you have a programmer's block, just take one of your old programs, okay? Any old program will do, which is, which doesn't have to be the same, but has to be somewhat similar, maybe. Or if you don't have anything, just start with the main, with hello world. Type it in and say, well, I've got the starting point. This is what I got to change to get to where I want, right? Then you'll know, right? So I've got this, and the starting point, the entry point is hard. Getting it down on paper will help you overcome programmer's block, okay? So now, can someone basically talk Mohammed through this program? And after that, we'll go ahead and embellish the program to say, hey, it's going to ask for the user input, the name, and then greet that user, right? That's all it's going to do. Very, very simple, right? So but you don't have to do the second part. Just get the hello world working first, okay? And don't look at any sources. You shouldn't be looking at some other hello world and saying, oh, this is what you've got to type. Try and do it from memory. And if you're getting stuck saying, oh, I don't know what comes after hash include, and you say, you can start thinking, right? Oh, I'm sorry, I forgot. And someone else could say, hey, angle bracket, okay? So it's kind of a group coding exercise. So start, okay? So someone should call out the code and Mohammed will type. I'll just keep watching, okay, and I'll help out. If you're irretrievably stuck, I will help out, absolutely.
So start with the hash include. And then the angled bracket or the greater than sign. IO streams.
Streams or stream?
Just one, STREAM.
Okay.
And then the other closed angle bracket, perfect. And then I think you want to do return and start on a new line. And then I think one for this style, one other, yeah, perfect. And then using space, namespace, space STD, with a semicolon. And then I think we want to do the a new line with the main function. So I don't know if we can do the int main or just main with the two parentheses open and close. Anybody remember if we needed?
Pretty sure we have to do the int.
Okay.
It's the int man.
And then the open and close parentheses.
Like that.
Yeah, exactly. And then I think you need to go into a new line.
Line.
Or wait, do you do the curly bracket here? The open curly bracket?
Yeah, you use space in the color spaces. And then they line 7.
I think it's also personal preference, just kind of
Yeah.
don't work both ways.
So Mohammed, I think you can do the open curly bracket here.
Right.
And then if you just hit enter and go to a new line, it should
Enter.
take the other one, yeah.
Go on, guys. Are you waiting for me, by the way? You should be. So all you need to do is just, send hello world out to the console. Okay, so that's all. And then we'll take it from there, right? We'll take it from there. So you need to, you're almost there.
So C out. And then quote, or wait, no, the two.
It's called left shift. Yeah, it doesn't matter. Some people call it the insertion operator. It's just basically the left shift operator. Yeah, what Adrian said.
And then quote hello world with the new line, new line or the slash n quote. And then I think you want to end it with a semicolon.
I think the slash n would, is it the other slash, like the other way?
Good catch.
The return 0 at the end of the function.
Hey, Simon, you can basically speak up, okay? Oh, I see. This is a reference. Yeah, okay. So by the way, Simon, this is, you could have asked this question. It'll help everybody also because
but
it's a general question.
someone is talking about the program, so.
Oh,
that's
I
why
see.
think
Okay. But generally, you can feel
don't
free.
want to,
Okay,
like,
you can feel free.
interpret it. Okay.
Okay, thanks for that. Yeah, system pause. We don't need it. The reason people put system pause is usually on GUI operating systems. Do you want me to talk about it? No, let's finish this, okay? And then I'll talk about it. Simon, you can remind me later on. You can close the chat.
Yeah.
Oh, I'm my chat window, right? All right. So Simon, if you remind me later, I'll talk about why we don't need that system pause stuff in the end. But let's not digress at this point. Okay. Now, this is a functional program, and you guys just reel it off from memory, and it should work. If you click run now, it'll work, right? If you click run now, it'll say hello world. Yes. There you go. So everything works. Why did it print two blank lines after that? That's really funny. You seem to have printed two blank lines. Maybe if you didn't have /n at all, it'll print one line. So maybe there's a default of one line that it prints by itself. Okay, all right, good. So this is a, is there a reason I missed that? Oh, wait a sec. Hey, by the way, the people are asking me questions in chat. Now, the thing is, chat is not visible to me. Okay, if someone types in a chat message, the first few lines or the first few words flashes on screen saying David said something and disappears. Okay, and after that I got to go and click on the chat bubble and open stuff and I got to search, and it's hard to do when we're in class. So the best bet is just wait for a small opening when someone's pausing the typing and say, hey, 1 sec, I got a question. That's the easiest way. Now, David asked a question and yeah. Right. So he said, why did we say int main, not void main? Okay. There is a reason for that. So when you run a program on any computer, when you run a program, does the program always succeed? No, right? Sometimes the program fails. And it could fail for a billion different reasons, because the program could say, get the person's name, right? And then the person says Mohammed, right? And then the program says, oh no, I don't know how to process names that begin with an M. Right? All the other names I can handle. So if it begins with an M, I'm going to die. Right? I'm not going to say hi Mohammed. Right? So so that's an error. The other thing could say when I started to run and I sent it to the console, but it so happened that the console was fried. Okay, or there was the console, the stream leading to the console, the pipe from console was broken. There's a hardware error. Some billion reasons things could not go right. So in that case, how does the operating system know that this program saying, hey, program, you got to run now? How does it know whether the program ran or not? Right? So the way we do that is that the main method, the entry point, the special function in the program will have to tell the operating system, right? This is I ran successfully or I failed. Okay, and that is the exit status, right? The return 0 says no errors. Did we put that in comments in that previous program we wrote? Right? So return 0 says there were no errors, 0 errors. So, but because it is returning a number, we say main returns an integer. That's why we have int main on the top, right? If you didn't have int main, you say void, that means it can return 0. It can't return a status at all. So the operating system will say run, and the program runs, but the main has no way of knowing, or the operating system has no way of knowing. But it so happens in C++, main always has to have a return status, because the operating system always needs to know what the exit status of the program is. Because the user, when they run the program, they're going to ask the operating system, hey, I told you to run that program. You know what? I told you to run Mohammed's program, and it ran and completed. Now you tell me what the exit status was. You know, did Mohammed say 0 or 1 or 5 trillion, or I don't know, right? So the user might ask the operating system, and the operating system wouldn't know. So that is why main always has a signature saying I return an integer. Right? I return an integer to the operating system that will give a status of how my program ran. Yeah, does that make sense, David?
Yeah, so does it like automatically, when you do that int main, will it automatically, like if errors out, give like a 1 or a 2, or is that something you also have to
No, you have to, right?
code?
In main, yeah,
Okay.
in main, you have to put the return value, right? So can we do this here? Say return, is there a terminal that, I don't know, does online GDB give you a Linux like terminal where you can actually, I'll try and find out later on for, you know, if there's an environment that lets you do that. I was trying to see if I could show you. Is there a terminal option? Well, maybe someone can Google and find out. Can you get a Linux terminal in online GDB? But we won't go into that now. But basically, what David is asking is that return 0 is it something that will be put in there automatically, or do you have to put it in? It is the programmer's responsibility, because it is the programmer who knows how your program dies, right? Because your program, when you start running in your main, you're going to say, I need the name, I need the address, I need so many other details before I can process this person, right? And maybe one of those details was missing. Maybe the social security number was missing, right? And so you want to exit with a status that says exit status 5, not 0, right? Because 1 could say name was missing, 2 could say the address was missing, and, you know, and so on, and 5 could say the social. So then you'd say return 5. If social security number is missing, return 5. So the programmer has to choose what the return status is. Does that make sense, David?
Yeah, so just to get this cleared, you cannot do a void main within C++, like it'll error out, or is it just we're practicing good coding right now?
Well, why don't we try it out? So turn the int into a void and compile it, and let's see what happens. Okay, so it says, you know, main must return int. Yeah.
Okay.
Did you see the error?
Yeah.
Yeah. So C++ kind of enforces that. I know in Java, I've actually forgotten, such a long time since I wrote in Java. I think in Java is void, is static void. In Java, I think it's void. It doesn't return anything. However, there is another way of signaling to the caller saying, hey, my program succeeded and failed. I've actually forgotten what it is. Every program gives you the opportunity to tell your caller, this I succeeded, or if I failed, this is how I failed. Hey, Charlene, you have a question?
Hi there. So I've noticed that some codes will use hashtag include studio.h. Is there any
stdio.h. Yeah.
STDIO.
Yeah, it sounds like studio, right? That's funny. It's yeah, it's actually standard IO, standard input output, and it sounds like studio, right? So stdio historically in the C language, okay, not C++. In C, stdio used to perform exactly the same things as IOStream does in C++. In fact, even here you can use stdio and it'll work, because every C program is also a C++ program. C++ is just, you know, C with a few more things added onto it. So if you take a C program and give it to C++ and say run it, you know, compile it, it'll compile, because C is also C++.
So they're interchangeable.
Not interchangeable. You can't take a C++ program and give it to C. You know, C doesn't understand C++, but C++ understands C.
Okay. All right. Thank you.
Yeah, because C++ is kind of the next generation C. You can think of it like that. And in C, IOStream and all those things and objects didn't exist. And so there was this library of input output functions, and all the declarations were stuck in a header file called stdio.h, right? The header file was called stdio.h. And in C programs, it was traditional to just include that on top, just like here, we're doing hash include IOStream. Does that make sense, Charlene?
Yes, that does. Thank you for the clarification.
Great, great, okay. Yeah, you need to remove the raised hand, otherwise it'll just keep showing up. And by the way, Caden, you also need to switch on your camera, okay? Unless you have, you know, or extenuating circumstances. Otherwise, Caden also you should turn on the camera at some point. Okay, all right. So now, no more questions. Now we can go and do that other part that I talked about. Basically, input output essentially, right? So what we're going to do now is inside of main, get rid of the cout hello world and all. Get rid of the cout, right? And then yeah, get rid of that. Now here, what we want to do is put a comment there. Put a comment there. Open a comment saying now we want to accept input from the console. Now we want to accept input from the console into our own variable, into our own string type variable, into our own string type variable. From console, yeah, from the our console, our console, OUR. Yeah, into a string type variable, into our own string type variable. String type, string.
Stream?
String, STRING.
Oh, string.
String type variable. Right? Variable. Var IABLE.
Can you repeat that?
VARIABLE. Yeah, okay, great. All right, now I enter. Now we're going to use the exact opposite of the left shift operator. Remember, the left shift operator takes something and sends it to cout, right? Now here we want to take cin and have it send something into our variable. Exactly the opposite. Yeah. So how do we do that? We say cin. Now we're going to do right shift into the, instead of left shift, you're going to do a right shift, right? And put spaces on either side because it's an operator. Yeah, okay. Now into our own variable, and that variable has got to be of type string. We don't have that yet. So let's go to the top, not the very top, immediately after the curly brace, inside of main. Yeah, hit enter. After the curly brace,
Oh.
Yeah, after. No, not before, after. Hit enter, right? Now here we're going to define a variable. A variable is basically, you know, a place for me to hold things that can keep changing. Meaning, give me something where I can put a value. Later on, I might say I want a different value. I'll take this one out and put another one in there. So essentially, you're getting a holding area. A variable is a holding area for you, and you can keep changing the contents as and when you want. Okay, so this is our variable, and our variable is going to be the user's name. So we'll call it username. Okay, so say string space. Yeah, yeah, great. String space. User underscore name. Yeah, and then semicolon and enter, right? Because the declaration part, previous paragraph, now the logic part. Yeah, and then also put a blank line above the return also, because the return is also a separate paragraph altogether, right? Yeah. Now cin, you have the greater than, double greater than, say username there. Username. Yeah. User underscore name. You got to be the same as the variable that you created. Yeah, semicolon. Right, enter. Now one more enter. Now, you know, user, start a comment there saying at this point, username contains the name typed in by the user. Contains the name typed in by the user. Contains what the user typed in. Contains what the user typed in. Yeah. All right. Yeah. Now hit enter. Now all you need to do is just do a cout, and then left shift. And here's the cool thing, okay? And that is the reason why it's an operator in C++ and not a function. It's very important, okay? It's an operator because now you can chain lots and lots of left shift operators, you know, on the same line. And you'll see that happening here, okay? Cout, and within quotes, you can say, hi there, and then comma, immediately after the comma, comma, and then close the quote there. And after the quote, no, it's just space after the comma, and then a quote. Yeah. Now after the quote, say another left shift operator, space, left shift, space. Yeah. Right. Yeah. Left shift. Left shift. Another. Yeah. Two more. Yeah. Right. Now, and now you can say username.
User underscore.
In the user underscore name. Yeah, exactly. Right. Now here's the cool thing. Okay, we're going to do a bunch of things here. Right. Now left shift one more time. Left shift one more time. And then open double quotes. Yeah. And say there's a space there. Okay, good. You say glad to meet you. Okay, full stop. Yeah, period. Now go to the end of the line. Don't put a /n. Go to the end of the line. Right now, left shift one more time. And say end L, ENDL. Okay, now that is basically the same as a /n character, except it does a few little more things, okay, which we don't really need to know the details of right now, but you'll find out eventually, right? End L is exactly the same as a /n, except that it will send things to the console, right? Send the line to the buffer, and also make sure that the line is flushed from some internal storage area into the screen. That's all it does, right? NDL will make sure that whatever is there gets flushed out to the screen and is not in some holding area saying, okay, I got some stuff to send to the screen, I'll send it out the next time, right? That's what because talking to the screen, talking to the keyboard, they're like billions of times more expensive to the CPU, right? From the CPU's perspective, talking to the console and then talking to the keyboard, very, very expensive things, right? Because it's device drivers involved. Anyway, actually, anytime interacting with humans is concerned, the CPU will say, oh, damn it, I got to talk to these damn humans again, because humans are like trillions of times slower than me. I can do things like this, but humans are slow, right? So humans are very, very slow. And for that reason, what we would do is when humans say, do this, and do this, the CPU will not keep doing this every time humans say, do this. It's very inefficient because humans are very slow. The CPU will also end up being very slow. So what the library does is when you say send it to the console, it'll just take it and stick it in some internal holding area called the buffer. Okay, and then when the CPU decides through with its own wise model of saying, oh, this is a good time to send things to the console, then it'll say, okay, now it seems like they're done sending stuff to me. I'll take what's in the holding area and send it to the console. So it'll just batch things up and do it all in one go. That's basically what buffering is, right? You'll hear the word bandied about a lot. People will say buffered output, buffered, this is buffered, and so on. What does it mean? All it means is when you buffer something, you don't do it immediately. Just keep holding on to it, right? So that you don't have to do many of those things. Hold on to it when it's accumulated and you think that you've got enough to send it, right? Then you do it one time, because the overhead of doing it, you only have to do it one for many of these instead of doing it one, for each. That's the difference. Okay. NDL will make sure that the line is actually sent out, right? It's not buffered. That's the only difference between /n and NDL. You can talk about this in the forums later on if you want. Okay. Now, if it's a semicolon after that, if you run this now, I bet that it will ask for your name and it'll greet you by the name too, right? Why is it not running? Is it running? Is it compiling?
That was actually.
Oh yeah, of course, yeah. All right, okay, all right. So no, it is running. It is waiting for user input. Now here, in the process of doing that, we also discovered a very important user interface issue, right? The C++ is not all about number crunching and in the backend. Okay, lots of people do highly user interactive stuff in C++. In fact, go to games, right? All these top games, many of them are written in C++, right? Even if it's written in other languages, eventually it gets filtered down, right? So it's very C++ like. So where was I going with that? So what was I talking about? I'm sorry, what was I talking about?
For the name.
I'm sorry? Oh, it'll come back to me. I'm sorry. Thank you.
We just don't have a prompt for asking the name.
Oh, yeah. Thank you. Was it David? Who said that?
Yeah.
Thank you, David. Okay, so the user interface issue here is that it is waiting for input from a user, from us, but we don't know because it hasn't told us, to type something in. Yes. So that is very bad from a UI perspective. That is bad. The user should not be left hanging in a lurch, right? And typically when a program crashes, that is also super bad because the program crashed when the user did not expect it to. It is much better if you think that the program cannot do something that the user wants it to do. It is better to tell the user, I can't do it, and then die on your own terms, rather than try to do it and not be able to do it and die in the process. And the user will say, that program is going to be deleted from my phone because it just crashed my phone. Yes, that's bad. So those are things that you'll get to learn eventually when you're building user interfaces and all. So we have to print a prompt, right? And say, type your name, but let's not do it now. Just type in a name, right? Type in Antonio, for example, right? Type in Antonio and it'll say, hi there, Antonio, glad to meet you. Right? A-N-T-O-N-I-O. Yeah. All right. Now, if you hit enter, it'll say, hi, Antonio. Hi there, Antonio. Oh, look, I thought you put a space after the comma. Oh, yeah. You need a space after the username, right? So inside before the word glad, put a comma and then a space. Yeah. Okay. Now, if you run it, you'll get the right behavior, except the G needs to be lowercase because it's part of the same sentence. So yeah. All right. So now, if you run it, you'll actually see the exact behavior that we had wanted. Except that it's still not asking for the prompt. We're going to fix that. Okay, we're going to fix that, right? So yeah, any name. It doesn't have to be Antonio, right? You can say Erica, and it'll say, hi, Erica. Right? So now, see, hi there, Antonio. Glad to meet you. Yeah, all right. So now it works, right? Now we'll fix this slightly so that we ask the user, so that the user is not, befuddled. Okay, so before we ask for the read it in, so let's go to line number 10 and hit enter. Yeah, line number 10, hit enter. Right now, put a comment there. Saying print a prompt to ask the user to type their name. Right? Print a prompt for the username or something like that. Yeah, print a prompt for the username. I think that's easier. Print a prompt for ask the user for their name. EIR. Yeah. Okay. All right. So hit enter, and then hit one more enter and go up so that it's a pretty different paragraph. All right. So now we just want to do a cout statement, that says, please enter your name within quotes. That's all. Hey, did it automatically make the C uppercase in cout, or did you put it? And then uppercase P because it's the beginning of the sentence, right? Please enter your name.
Excuse me, Professor. Could we use Could we use get line instead of cin because our
totally,
user
Hannah,
input
yes.
is a string?
Yes, Hannah. Yes, absolutely. Okay. In fact, I would starting from next class maybe we'll wait for using get line like Hannah suggested is the better way to get user input, and I'll go to the reasons later on in a different lecture. Okay, maybe next week. Get line is a better way to get user input rather than using cin like this. But we won't do it right now. Hannah, you're right. Okay, get line is the better way to get user input. And I'm not doing it for a very specific reason, but and I'll tell you the reason later on. Okay. Now after that, please enter your name. Put a colon. Right. Put a colon. Yeah. Put a colon. No, not there. Inside after NAME, put a colon, not a semicolon. Put a colon. All right. Good. Right. So that is a prompt. So it'll print the prompt, and it's going to wait for you to type the name in. Now, one thing I've noticed in user interfaces is that there's actually very few user interfaces where you actually have to type user input these days. But back in the day, or if you look at some programs where you actually have to type into the console, is it a good experience if it asks you to type something in and then goes to the next line, and then you get a blank line altogether to type in your response? It works for some things, right? But if it's just asking for your name or one thing or some small thing, it is always aesthetically better to get the input on the same line as the prompt, not on the next line. Yeah, so we're not going to do a /n there. Is that okay? We're not going to do a /n. Now, if you run this now, a semicolon right at the end, Now, actually, no, don't run it yet. Don't run it yet. If you run it now, the behavior you would expect to see, right? The behavior you would expect to see, technically, is it will not print the prompt. It will still ask for the username. We'll get exactly the same behavior. Technically, right? That's not what is going to happen, and I'll tell you why it doesn't happen. But that is what you would, based on what I've told you so far, that is what you would expect to happen, because cout sent the string to, that operator sent the string to cout, but cout said, the programmer asked me to send something to the console. Who knows if they're going to send me more stuff, right? And talking to the console is expensive, so I'm going to hang on to it. So it's not going to print it out. It's going to hang on to it. So technically, there's no guarantee that it'll come out on screen. So typically what people do when they send something to the screen and don't have a /n or endl, /n and endl, they're both signals to the library saying, well, you know what, there's a new line, send it out, flush the buffer right now. Because when you have a new line, that is a heuristic followed by the library saying, hey, there's a new line. That means that the user has done something and they're waiting for something. Let's flush everything to the buffer. But we're not doing a new line here. That means that could potentially be held in the buffer. So what people typically do is on the next line, put another blank line there, but open a comment and say, typically the previous, you know what, these comments are not things you would be writing in real programs later on. We're putting these comments there only for the purpose of students who are missing these classes, okay? Students who are not attending lectures, who want to look at the program later on and try to understand what we did, they don't have to look at the whole video, right? Because otherwise they'll have to look at the video and scrub it and get to the point and say that's why they're doing it. But with the comments, they can just look at the program. They don't have to look at the video. Okay, that's the only reason we're putting so many comments. Later on, when you get to writing professional code, or even later on in the questing, you would really strive to minimize the comments. Okay, one of the greatest dark arts, not dark in this, it's not bad. One of the esoteric arts in programming is how to reduce the amount of comments but still keep the program equally clear. Okay, because it is easy to get rid of all the comments, but then the program becomes hard to read. Right. On the other hand, it's possible to put in lots and lots of comments, and the program is hidden in there. You got to really look for the lines to find the program. That's also bad. Okay, so this is really something that will only come with practice. We are saying what comments are necessary and what comments are not, and that to a large extent is dependent on the programs and the programmers who are your peers. Okay, so in the beginning, as a newbie, you'll be working with other newbies too. Entry-level programmers, right? So you'll find lots of comments. If you look at entry-level programmers' comments, there'll be lots of comments because those comments are also useful for fellow newbies who are going to look at the code, right? But as you get better and better with programming, the comments will start getting smaller and smaller, okay? And when you go to expert-level programs, you'll see large chunks of code, no comments at all, right? But there will still be comments. There'll be one comment that'll be like super duper useful, right? That an expert will know exactly. As soon as the expert reads that one comment, they'll know exactly what the 50 lines immediately after that will do, right? So you'll get into that mind swing, right? So eventually, but right now we'll do a lot of comments. Okay, so typically the above, oh, by the way, you're missing the left shift on the previous cout. On the previous cout, you need the left shift operator, yeah? All right, so typically the above statement would not have sent the prompt to the console. Yeah, would have not sent the prompt to the console, to the screen. On the next line. On the next line, you can say, instead, it will be held in a special holding area called the buffer.
They still do the slashes.
Oh yeah, all comments, yeah. Instead, it will be held in a special holding area called the buffer. Waiting for an opportune time when the library can, waiting for a good time the library can send it, right? We're waiting for a special holding area called a buffer, right? And you can put the buffer within quotes because it's a common, it's things that people use. Right? On the next line, you can say buffer instead of until until an opportune time, until a good time determined by the library, until a good time determined by the library. Okay. And only one L for until. Right? So, and
Is there a
library.
max
library.
buffer size?
Hmm?
Is there a max buffer size?
Actually, I don't know. You can Google and find out if there's a max buffer size. I don't think there's a max buffer size. It's probably limited by stacks and other, other things. Maybe there is a max buffer size. You can Google and find out on Stack Overflow. But most of the time, buffers don't get filled up like that. Okay, most of the time it's holding stuff, and then the programmer will just flush it using cout.flush. Okay, or an endl or a /n arrives, that'll also flush it. So that's what happens, and that's a good question, by the way. Who asked that, by the way? What is the maximum buffer size? Someone did ask that question. David, yeah, thank you. Right, it's a good question. All right, so until a good time determined by the library, or the user explicitly forces a flush using the statement explicitly forces it to flush, forces a flush. On the next line, you can say flush using, comment using the statement cout.flush and then open close semicolon. Right, open close parentheses, open close parentheses. Yeah, and then a semicolon at the end. No, at the end, semicolon at the end. Semicolon at the end. But on the next line, we'll say, but in this case, it will flush because our next statement is accepting input from the user, right? That is also a case when the flush happens, right? When you accept input from the user, accept input via the console, the flush will also happen. The flush because this our next statement accepts input from the user. Our next statement accepts input from the user, and that is also an automatic flush event. The next line is, and that is also an automatic. Oh, is it 10 o'clock already? Yeah. Okay. Yeah. All right. So some people have to go at 10. I didn't realize it's 9:38, but we're pretty close to the program's end. Okay. And then I'll leave it with a small challenge. Okay. That you can complete and then post and share on the forums and all. Okay. And we're almost done. Okay. Angela, was it Angela? I forgot. Okay. Almost done here. Okay. Accept input from the user, which is also an automatic flush event, And an automatic flush event. Yeah. Flush signal. Okay, that's all. I hope the comment is explanatory enough. And by the way, you should also put yourself in the shoes of people who are absent today, because your students, you'll also have a good idea of whether the comment is good enough. If you had missed the lecture, was the comment good enough and all? Otherwise, you should also chime in and say, hey, let's change this and so on. All right, so good. All right, so now if you run this, you'll see the prompt, and then you can type in the right thing, and then it'll do the right there. You see it, right? You got the prompt. Now you're going to type in a name. Let's type in Karthik, right? Karthik. No. All right. Okay, Karthik. All right. Karthik is one of our classmates, right? Karthik, but doesn't matter. Okay. Okay. If you hit enter, it'll say, "Hi there, Karthik. Glad to meet you." All right. So we've done this. Now, first of all, before we go on to the next step, in which we're going to do something very, very simple. Okay, very simple. Now, after CN that thing there, hit enter. Okay, hit enter. Yeah, there, enter. One more time, right? Open a comment and say to do all uppercase. This is your not homework really, but it's a challenge that you can work on and share. Okay. Now, to do what we want to do is change the user's name. Yeah, change the user's name by replacing all the vowels, right, with some random vowel. Okay, that's all. You're going to take the name and just leave all the consonants in place, but change the vowels into some other, right? So with a random vowel. by replacing all the vowels with a random vowel. And I'll get you started on this. Okay, I'll get you started on this so you can wrap it up. Okay, with a random vowel. So on the next line, you can say string. No, you can say string. This is string space modified underscore name. Modified underscore name equals name equals. Now we're going to create a brand new function just like main. Okay, except this function is not going to be called by main. It's going to be called by, it's not going to be called by the operating system. It's going to be called by us in main. That's all right. So you're going to say modified name equals, right? And you can say, well, what do we call this function? We call it yeah, I don't know, we call it change name or something like that. I was just trying to say yeah, change underscore name. Right? And then open parentheses after that, open parentheses, right? And typically I don't have a space when you're doing a function call, unlike a yeah, there you go. That space is yeah, right? Because then operators and function calls, it's easier to design the grid, right? So inside you're going to pass username as a parameter. Type username.
Underscore or no underscore?
Underscore name. Okay. Now put a semicolon at the end. Right, and then on the next line, actually, you know what? Put the comment above that line. Put the yeah, after the to do. Let's open another comment, and there after the to do, after the to do line, one more. Yeah, okay, all right. So what we want to do is we will create a function called change name. We will create a function called change name, which will be given the supplied username as a parameter. Supplied. Yeah, supplied, LIED, supplied. And there's an extra I, yeah. Supplied name as a parameter, right? As a parameter. And on the next line, you can say, and it will return the changed name. All right. So now let's go ahead and define that function up there. So we'll define that function above int main. Go above int main, line number 6, and hit enter. One more time. And then go up. So right now here we're going to say string space change underscore name. Is that what we called it? Yeah, change underscore name, right? Open parentheses. And then the parameter is going to be a string, say string. And then it says, just say name, right? It's being given something. Right, and then go to the end, curly brace, and then hit enter, and then curly brace at the end, so we get the body, right? And space before the curly brace too, right? Yeah, and then yeah, there you go. Hit enter there. Yeah, yeah. Well, one more enter, and then put a curly brace there. Now the body of the function will go in there. Now here, let's put a comment above line 6, right? Go to line 6 and hit enter. Yeah, open comments, and here we're going to say this is a function that will replace, that'll fiddle with name and return a new name, right? That'll fiddle with name and return a new name. And you can each one of you can decide on how you're going to fiddle with the name yourself, right? Maybe Erica would say, I'm going to change all the vowels to random vowels. Someone else could say, I'm going to change consonants. Someone else could say, I'm going to do something else completely, right?Maybe insert spaces between all the letters. You can do whatever you want, okay? So each person does their own thing and you can share it. Okay, so they're all different things. Now inside the oh, I see, this function will change it and return a name. That's great. Okay, now let's go inside the function. Go into the function, and now let's do the brain dead simple thing of saying this function is not going to do anything at all. You tell me to change the name, I'll just give it back to you like that. Okay, let's see if that works. If that works, yeah. So inside the function, change name. Just say return name. Just say return name right there. No, inside the function, inside the name. Yeah, there. Inside. On line 9.
Line 9.
Yeah, enter indent in. No, indent in. Yeah, all right. Say return name.
Underscore or just return name?
No, just name, the parameter name. You got the name parameter up there, right?
Oh.
String name, and semicolon. Right now, put a comment on the right of it that says this doesn't do anything. Returns the name as is. Return name as is. Returns the name as is. Returns the name as is. Yeah. Now, if you run this, you'll see exactly the same behavior as before, because change name is not doing anything at all. All right. You type something in, say Minghua, and it'll just say Minghua. Right. It won't do anything.
Are you still there?
Or you say, just Simon or something. It says Simon, or one word, right? Simon, right? You'll just say, yeah, hit enter. It'll just say Simon again. It says, hi there, Simon, right? Now, however, now we've got control. Wait, we just got in and inserted a point of control there. Now we got the name. We can do anything to the name, and then it'll change the rest of the, program. So in that function, instead of just returning name, just say return name plus name space plus, and then within quotes, you say 3 uppercase I, right? Right? That's like Simon III, like the King Simon III. Okay. Now that's all that happens. That's right. Now, if you run this now, you'll say, my name is Simon, and you'll say, hi, Simon III. Glad to meet you. Yes. Right. Hey, why didn't it say Simon III? Oh yeah. No. In the way further down in main. Go to main. We forgot to change something in main. See, it's all bugging. It's bugs. We're debugging it. In main, go to line. Yeah, where you have no 35, line 35, I think.
35.
36. Yeah, change username to change name. Change the name. Change.
Oh,
Modified name. Now, if you run now, you'll see, type in Justin. It'll say
Underscore or
Justin
no underscore?
Modified underscore. It's got to be the same as a variable. You create a variable using it. Yeah. Right. Now you type in Justin with a capital J. You'll say, hi, Justin III. Glad to meet you.
Yeah.
Oh, no spaces. All right. Now, basically we're fiddling with it, right? So you put in the spaces before there. Okay. Now, the challenge here is going one step beyond this, and it's okay if you don't get to it, but it's going to be fun if you try it. You can Google and use resources. You can read our modules too. So now what we want to do is go to the function modify name on line 9 and put a comment before a return. Comment out the return line. Comment out the return line. So go to the beginning of line 9 before the R and hit two forward slashes there. Okay. Now, because that's not what we're going to do. What we want to do is hit enter at the end of the line, hit enter at the end of the line, hit enter. Right. What we want to do is we want to go through the name one character at a time and then change vowels to random vowels. Okay, now you know what? We didn't go through rand and things like that, and we're out of time. Maybe we'll get to it next class. But if you do some research, it's very simple actually. If you do some research and try it on your own, we'll do it. Otherwise, we'll start off with this on Thursday. But we want to go through our name and change the name one character at a time, or one vowel at a time to a different random vowel. Okay, change all the vowels to random vowels. Okay. And it's one character at a time. And if the character is a vowel, change it to a random vowel. Well, there's so many concepts that we haven't yet covered, as if and so on and so forth, and then looping and strings. Yeah, so that is the only thing I don't like about the first few lectures in CS2A, is that it's the first 2 lectures, we don't have a lot of stuff to work with. We're just doing the bits, right? But after lecture 5 or lecture 3, even after lecture 3, we have a lot of material to work with, right? We have loops and we have branching statements, and then we can do more interesting things. Right now, we're constrained. We can't do so many interesting things. So we want to go through the name to another random vowel, to random vowels, and then find and return the change name. That's all we have to do. If you want now, and if you have time, I can. And by the way, someone has to go. I think Angela has to go. Oh, she's gone. Okay, good. Right. So if you want, I can walk you through the steps. Now, I won't have time to explain the steps, but it's just two lines, right? I can walk you through the steps and you can brainstorm these steps on your own and discuss them maybe, right? So why don't I do that, okay? What time is it?
I have a quick question.
Yeah, sure, David, go ahead.
So as far as the organization of the functions, does it matter that where they come? Like, does the change name have to be before main, or because it's compiled, does it not matter?
Good question, David. Okay. All right. Okay. As far as organizing these, your program goes, David is asking, should the function change name go at the top or the bottom or in a completely different file? Right? You can have it in a different file too. And that's all of that is fine. Eventually, you will actually take them out and put them in different files and organize your project in ways. The reason we put it up there is because if we didn't do it up there, the compiler will complain when it encounters our call to that function and saying, hey, you're calling a function called change name, but I don't see it anywhere. So what should I do? And are you calling it correctly? You're giving it a string. Does the function actually accept a string, or does it require a number? So all those questions will be asked by the compiler, and the compiler will say, I can't compile it. So in order to prevent that, what people do is that I have this function. It's in a separate file. However, right, you don't have to be thrown off track, and you can tell the compiler, dear compiler, don't worry, okay? That function is there. To set your mind at ease, here's how the function will look, right? So you can give a declaration of the function, not the definition of the function. You can declare the function up right at the very top, saying, you know, there's this one line here that says this is the function, and that function will be there in some file. You can put declarations at the top, and that will make sure that you can put your functions anywhere you want, right? Now, we didn't do that. That is why we put the function right at the top. Then if you put the function at the top, then the compiler, it doesn't need to look for the declaration because it's already seen the function before it comes to the place where you call the function. Does it answer your question, David?
Yes, it does. Thank you.
Great. Okay. Now, so let me just go through the it's going to involve a loop and one more function call. So let's go into that function, change name, right? Go to the function change name. 2 minutes, okay? Just bear with me for 2 minutes, and I won't explain it. We can explain it next class, or one of you can explain it to another person in the subreddit, okay? All right. So go to the end of line 10 and hit enter. End of line 10 and hit enter. Right now, here's what we're going to do. So we say string new name equals. I'll just say string new name. Or new name.
Space.
Yeah, new name. Underscore. Yeah, name equals blank string. Okay, blank string.
Equals.
Empty double quotes. Yeah. All right. In fact, we can do better than this. We can do slightly better than this, right? New name equals name. Just say new name equals name, which means we're going to start with the name and then go through it and change it, right? So name, right? Enter. It's a semicolon and enter. Right. Now, here's what we're going to do. So one more blank line, right? Now, this is a structure that you can Google and find out, or it's in the modules, right? One more enter. Right? Here's where for, F-O-R, it's a loop, right? We only talk about this in week 3, but you know what the hell? It's all very simple, and we'll talk about this so many times, it'll be simple eventually, right? So for, open parentheses, right? You say size underscore t. Size underscore t is nothing but an integer that is guaranteed to be positive. Now, going back to data representation, if you say take an integer, you can represent an integer in 16 bits, let's say. It's short integer, 16 bits. However, if you want to store both positive and negative quantities in there, the leftmost bit is gone. It's a sign bit, isn't it? You only have 15 bits to store the integer. But if you know for sure that the quantity is never going to be negative, you can say, I want all 16 bits. I don't want to lose 1 bit to the sign bit. I want all 16 bits. Then you can say, I want an unsigned integer. That means it'll not use 2's complement. It'll just use raw binary for the integer in the background. Okay, so that is called an unsigned integer. But because unsigned integer is such a big thing, we say size t, which is also a short, size t is a synonym, another name for unsigned long integer, right? Size t space I, so size t space I equals 0, space I equals 0, and put spaces on both sides of the equals. Yeah, and then a semicolon after the 0. Space, right? I less than, and then spaces on either side, yeah, less than, and then it is name dot length, okay, name dot length.
Length.
I think that's length, yeah, open, close. I think that's what it is, right? We got to look it up if it doesn't, if it's not the case, and open, close after the length. Open, close, yeah, semicolon.
Then everything.
Yeah, right there. Yeah, this is the entire thing is a for statement. Like I said, we'll go to the details of the for statement later on, but you can Google and find out too. So I'm just doing it here for the sake of completeness, so that you have something to work with. Okay. No, after the semicolon, you want to say I plus plus.
I plus.
Okay, there you go. So on the next line, you're going to say on the next line, you can say it's a curly brace too. Curly brace. You will, let's say curly brace there. Yeah.
Line 14 or the end of line?
Your style, okay. Do it. We want the block of 4. After the 4, you want a curly brace. Space curly brace, yeah. Space curly brace. Hit enter. All right, great. Okay. So here you're going to say if new name.
A statement.
If new name. Oh, I know. Yeah, I'm sorry. We haven't covered if. Yeah, if open parentheses. All right, here we go. Open parentheses. No. If open parentheses. That's all. Yeah, and within the parentheses, you're going to say new name, new underscore name. Yeah, square bracket I.
In between the square bracket.
Square bracket. Square bracket is like this, not curly brace. Square. I think it's shift. Yeah. Square bracket and then I inside of there. Yeah, I. Now after that you say double equals. Space double equals. No, equals.
Oh,
Equals. And then here you can say the letter A within single quotes. Okay, the letter A within single quotes. Within single quotes.
With single quotes.
Oh, well, yeah, single quotes are
like an apostrophe.
Same key as the double quote, except it's no shift.
Oh.
Yeah. Okay. Right. Now we'll do more. Right. We'll do a couple more, and then you can add more too. Right. After the closing double quote, say space, 2 vertical bars. Yeah. Or a new name square bracket I equals. No. That 2 vertical bars is called OR. Right?
Oh,
the 2 vertical bars is called OR. In fact, you can use OR in the new versions of C++ out there. C++, I don't know, 21, something like that. You can use OR, but lots of programmers just prefer to use 2 vertical bars. Okay, so we'll just stick with vertical bars, right? So or now new name square bracket I equals E. So right now we're only going to change A and E. Okay, and you can fiddle with this later on to do more if you want. Right, and a new name square bracket I. Yeah, and no space before the square bracket. Right. Yeah, and then same double equals E lowercase. And within quotes.
Single
yeah?
or double quotes?
Within single quotes. So individual characters are given in single quotes. Strings are given in double quotes in C++. The reason for giving the single characters in single quotes is that when a character is in single quotes, that is actually an integer. That is the ASCII value of the character. So if you have the capital letter A, uppercase A within single quotes, it is actually the value 65, because 65 in ASCII is uppercase A. So it's the same as an integer. So that's the distinction you can find out. Okay. So on the next line, you can say, yeah. So you can say, yeah. So indent in, 4 spaces in. Yeah. And say new name square bracket I, I equals get a random vowel. Okay, so get random vowel, get underscore random underscore vowel. And that again is another function. We're going to define another function. Very simple, one line function right above that. And we're yeah, and then open close, open close, open close, semicolon. Open close, or open parentheses, yeah, semicolon. Right? Semicolon at the end. And then at the end of this function on line 17, hit enter on line 17. Yeah, hit enter. And say return new name right there, return new name. I think you have two blank lines above there, but you can return new name and then get rid of one of blank lines. Okay, and we're almost done. We just need to define that get a random val, and that's a piece of cake. Okay, and we'll just do that now. Semicolon, semicolon after that. Now go to the line above, go to line 6 and hit enter again. Go to line 6 and hit enter again. And here, all you're going to do is one more enter, and then go up. So it's a new function, isn't it? Right? Yeah, right. So here say char, char, right? Space, get random vowel.
Underscore?
Get underscore random. We're defining that function. We're defining that function. Get random underscore vowel. Yeah, open close, open close. And then on the next line, yeah, curly brace, no, curly brace, space, curly brace. Yeah, on the next line, essentially you're going to say, let's say char, no, it basically says string, says string, vowels equals, and then within double quotes, you say A, E, I, O, U. Right? Now, on the next line, semicolon at the end, and all you're going to do here is you're going to take a random character from there and return it. That's all it's going to do, isn't it? Because you've got all the vowels there, you're going to pick a random one and return it. That's what get random vowel does. Yeah. So how do we get a random vowel? So what we're going to do again. So do a little bit of research maybe and share this in the forums. It'll be interesting. So you say return vowels, square bracket. We're doing a lot of stuff here, which is really cool, and I think it's going to be interesting and useful too. And then we can spend more time on this next class if you want. Okay, but it's actually interesting, right? Vowels. Right. So here's what we're going to do. So we're going to say vowels dot length. Vowels dot. No, hang on. Before you the vowels open, say rand, open close, rand, open close. No, not random. Rand, just rand. Rand, yeah, open close. Open close parentheses. Yeah, I'm sorry I'm having to peer like this because I set the font size, well, because I can get more of you in the gallery, I got to reduce the size of the thing here. Okay. Open close after rand, open close immediately after rand.
Oh,
yeah, no, yeah, there you go. All right, rand. No, you don't have the square bracket.
I don't need that.
No, you need the square bracket after vowels. After vowels, you need square bracket. Open square bracket there. So open square bracket. Yeah. And then rand. After rand, you're going to say percent. All right.
And
after rand,
parentheses.
No, after the parentheses. After the parentheses, you're going to say space, percent, space.
Percent.
No, percent sign. Yeah, space. And you're going to say rand percent vowels dot length. Okay, now I can explain this very briefly. Now, by the way, your square brackets are all messed up. You need to take the closing square bracket and put it there at the end. And open close for length. Length is a function, right? Length, open close. Length after length, you want open close. Okay, and now square bracket, close square bracket, semicolon. Okay, now so this is a very simple one-line statement, and it may look very perplexing in beginning, but it's actually very simple, and you'll get the hang of it. And I'll explain it later on. Now, when you run this, it is going. What it does is rand returns a random number. But this random number is going to be huge. You don't know what it is, right? It could be huge. But our vowels, however, has only 5 letters in it. So if you're going to index into vowels and say, give me the first character, give me the second character, you have to be only between 1 and 5. You can't say, you know, I've only got 5 letters, give me the 15th character. Doesn't work, right? So basically you want a number between 0 and 5, 0, 1, 2, 3, 4. Those are the only 4 numbers you want. But rand is going to give you a big number. Yes. So what we do here is take rand and do what we, you know, Omar and Adrian did last class, is basically take it, divide it, and take the remainder after dividing by 5 or dividing by the length, right? In this case, the length is 5, vowels at length is 5. So we take the random number, divide by 5, and take the remainder. And the remainder is guaranteed to be a random number between 0 and 5. Yes? Now using that, you index into vowels and you get that character out of the vowel string. Yes, but it takes a little while. It takes a little while to pore over this because, you know, typically in beginner classes, what we just did, most instructors will split it up into 5 or 6 statements so that each one is very, very clear. So everybody understands exactly what's going on. But we took the shortcut and clubbed it all together. Pretty much this is how professionals would write it, right? In one line, bam, like that. And we did it, and it's not done. It's not done in beginner classes, but we did it because I can look at you guys and I think that you'll be able to figure this out easily. Okay, that's why I did it. If this is befuddling to you, I'll go over it again next class, not today, right? Because we're out of time. I'll go over it again. You can also do some research and share in the forums like Omar did and all, right? So you can share. But this is essentially what it does. The one more thing we need to do, just go to main. Just go to one small thing, okay? Go to main. After string username, right? After string username, hit enter.
Oh, which line?
On line 28. Go to line 28 and hit enter, right? One more enter, right? Now here, we're going to do something which I'm not going to explain. It's in the recordings, it's in the forums. You can Google it and find out. If you still don't understand it, I can explain it next class. We're going to type something in, right? And say S-R-A-N-D, S-RAND, right? Open parentheses. Inside the parentheses, you're going to say another parentheses, open another parentheses. And inside that, you're going to say unsigned, okay? Unsigned. And outside of the inner parentheses, right? Outside of the inner parentheses, right? Space, not there. Unsigned, past tense, unsigned. Ed. Yeah, right. Now there, outside of the inner parentheses, there you want to say time, T-I-M-E, time. Yeah, open parentheses. And then 0, uppercase L. Okay. Now I'll put a comment there that gives you a hint as to what it's doing, and then you can research and find out more. And now go to the end and put semicolon. Go to the end and put semicolon. Get rid of the space before the final parentheses, and put a space before the T. Put a space before the T, right? And put a semicolon at the end. And a comment right there. Comment right there, right? Yeah. And say this statement makes sure that rand will return a brand new random number every time it's called, right? Every time the program starts, every time rand open close, because that's a function you're calling, right? Rand open close there. Makes sure, not make, yeah, makes sure, space sure, makes space sure. Rand returns a new random number every time the program is started up. Each time, right? Each time. Now you can experiment by commenting it out, right? You can experiment by commenting it out, and you'll know what actually it does and what it does, right? Yeah. Oh no, opened as it has an E at the end, but that's okay, right? You can fix those things later, right? So now if you run this now, and mind you, right, we're only changing A and E. If you look in that if statement up there, but there's 5 vowels, so you got to check if it's equal to A or E or I or O or U. You got to change all of them. So you got more of those matchings to make that. So if you run it now and type in I don't know, someone who's got a name A in their name, and it's got to be lowercase a, Namrata, right? So type in Namrata, E, Who has A and E? That's okay. We'll just take Namrata, and both of the A's will be replaced, I think, by random vowels.
How do you spell it?
N-A-M-R-A-T-A. R-A-T-A. Yeah, all right. T-H-A is fine. I don't know. Oh, no, it says T-A. All right. Now, if you hit enter, there you go. All right. Hi, Numritu. Glad to meet you. All right. So what it did was it just went through the letters, and every time it found one of those target letters that matched, it changed it to something else. That's all. Very simple, isn't it? Okay. Now you can take this to the next level. You can play with this now. You got the basic workings there. And you can if you comment out the srand line and run it, you'll get the same change every time, right? However, if you put the srand thing back again, every time you run it, it'll be a different name. Maybe it's a Numritu first, and then it'll be Namriti, or every time it'll be different, right? Because srand is now seeding. It's called seeding. Seeding the random number generated, give you a different random number each time. That's all. Okay. Now, is this? I think it's sufficient for today. What time is it? It is past 10, actually. Thank you all for sticking around, right? Even past the end of class. I know some of you had to leave for the other classes that you're enrolled in, but thank you all. But was this class useful? Was this too fast or too slow? Give me some feedback, okay? Was this too fast? No, good. All right, thank you. Right. By the way, I know some people are saying it's good speed and not fast, but maybe some people do feel it's too fast, but they're not speaking up. Okay, though they are the ones I'm worried about. Okay, so if you feel that it was too fast for you, just send me a message. Okay, send me a message and say, or you can even respond to your classmates in the subreddits. All right, and say, hey, this program we wrote today, can someone explain this? Right, and someone else will jump in and say, hey, this is what it does. And so make sure you're on top of this. Change this program to make sure it handles all of the vowels, and then maybe use your own change name, right? Maybe it's not going to do the vowels. Maybe it'll do consonants. Maybe it'll add a dot junior, right? Justin Junior the third. I don't know. Do whatever you want. Okay. So the world is your oyster, and feel free to have a ball. Okay. Have a great time fiddling with it. At the end of the day, you'll only get really good at computer programming when we figure out how we can make the computer do cool things for us, right? Because otherwise it's just a chore, doing some. So you got to figure out what are the interesting things that I can do that make it's fun for me to use, right? Then programming will become as much fun as a Fortnite or some other game, because it gives you fun, right? So you make it fun, it'll give you fun, and then you can keep doing more and more of it. And so thank you all for sticking around. I hope this class was useful. So next class, we'll just take this to the next level, okay? And we'll start developing more and more programs just like this, okay? Thank you, Mo. Right, Mohammed, thank you so much for typing with us today. Hopefully next class, someone else will have a chance. Everybody will get a chance, and after everybody's had a chance, we can recycle again and go back, and everybody will get a second chance and so on. But there'll be lots and lots of opportunities, okay? So thanks. All right, so have a great rest of the day, good week, and I will see you on Thursday. Okay, bye.
Bye. Thank you.
Thank you.
Bye. Thank you.
Thank you.
Professor?
Yeah, sure. Simon.
Yeah, okay. Can I share screen?
Oh, Omar's gone. No, not Omar. Mohammed is gone. Well, he'll probably post it in the Reddit, and then you can refer to it in.
Okay.
But if you have it in your memory, you can say what is it? What is it?
Oh, I was gonna say, what did you need? Because I have a screen with all of it on it. If you needed the what he typed or something.
Oh, maybe Erica can share it.
I think I
that what you
can
needed?
share the screen now. Let me see. Can you see it?
You can see your whole screen.
Yeah. That's why. Like, I'm a little bit confused about the student name. So I just type my name on it and grab it to. Let's see.
Oh, yeah. When you
this,
submit
right?
to the questing site, you need to type your student ID.
/ student name and add your name, right?
No, student ID, and it should be your ID there.
So it's student ID.
Yeah, you have a student ID, right?
Yeah.
So that's what you'll put there. When you submit to the questing site, you have to put your student ID.
Okay. Good.
Does it make sense?
Yeah. Also, like, can I use the standard cout to like print the hello world?
Can you make cout print hello world? Well,
See it? Can I see it?
I can see it. Yeah. So what is it?
Yeah, it is good because like you're teaching us another way to like print the hello world out. So I don't know the system can configure out, or I must
I'm
use
not
that
sure I
way.
understand.
I think he's talking
I'm
about
not-
the STD semicolon that's in the front of
Oh, yeah.
Yeah.
So yeah, you don't need the STD because you're saying using namespace STD right at the top. If you say that, you don't need the STD qualification. So
Okay.
some people would not put the using namespace on top, then they have to do STD double colon for CO. Yeah, does it make sense?
Yeah, it makes sense. All right.
All right. Okay, I'll see you guys later.
See ya.
Bye.
Bye.